Okay, so today's lesson is on simultaneous equation, which involves non-linear equation. Okay, we will see one linear, one non-linear. Okay, so in our previous lesson, we have defined our linear equation as equation with the highest power of 1. Okay, an example of that is anything that is in a form of y equals 2mx plus c. Okay, and graphically that will be a straight line. So that is linear equation. Now how about non-linear equation? From the word non-linear means that it is not a straight line. Okay, so non-linear equations are equations that appear as a curve. It is not a straight line but a curve. And non-linear equations will have highest variable 2 or more. Okay, anything that is not a curve, well, it says 2 or more here, but I will give you an example later on. But um uh basically anything that is not a straight line equation, that is what we call as non-linear equation. So examples of non-linear equation, you should know at least one by now. Okay, what we had before was, and we have been talking about this equation from the start of our lesson, which is the quadratic equation. Okay, quadratic equation. So anything in the form of, let's say, 2x squared plus 10x minus 5. So anything in the form of ax squared plus bx plus c. Okay, quadratic equation, that's non-linear, and we have seen the graph of a quadratic equation. And we can also have, let's say, for example, y equals to x cubed minus 1. X cubed, so it has the highest power of 3. Okay, the graph of x cubed will be something like that. Okay, so it is a curve, it is not a straight line. And we also have, for example, y equals to 8 over x. 8 over x is a curve. Okay, it has a power of -1 actually. Okay, it's not 2 or more, but basically non-linear equation is anything that is not a straight line. So any guess how does 8 over x graph looks like? Okay, well, it has two parts. It looks something like that. Okay, something like that. Okay, we will come across these functions at the later topics. But now, these are examples of non-linear equations. Okay, non-linear equations are basically anything that is not a curve, that appears as a curve and not a straight line. Okay, guys, now simultaneous equation, for non-linear equation, we use substitution method. Okay, so in our previous lesson for linear equation, most of you preferred elimination method. Okay, substitution method can be used for linear equation, but we have seen that certain times the working will be longer. Okay, but when we have non-linear, so if you can see here our example, 2x plus y equals to 4, that is, if you rearrange it, it will take a form of y equals to mx plus c. So this is our linear equation. So the next one is our non-linear equation. Okay, and normally when we have nonlinear equation, we will be using substitution method. And when we use a substitution method, it's basically you want to rearrange your linear equation or whichever that's simpler to make x or y the subject. And then you substitute it into the second equation. Okay, so let's have a look. The first one, we say label the equation. So yes, same thing. We will always label our equation. That will be our first equation. And the second equation, y squared plus 5 equals to 4x. Now next, you want to make one of these equation and then you make x or y the subject. Now, for example, I can take equation 2 and make x the subject. But notice that I have a coefficient of 4 here. If I make x the subject, I will have y squared plus 5 over 4. We can do that, okay? We can substitute. So let's say if I make x the subject from equation 2, I get y squared plus 5 over 4. Now what I do is I substitute this into here. Yeah? But I will first try to avoid fractions where it is possible. Okay, so instead of taking that, let's see if we make our linear equation. Let's see if I make my linear equation x or y the subject. So notice that in my linear equation, my y here is a coefficient of 1. So I can make y the subject. And in that way, I will get y equals to 4 minus 2x. No fraction. Okay, so either one works. Okay, you want to take here, make x the subject, or you want to make y here the subject. You can do either or, but I would suggest to avoid fraction where it is possible. So now what I will do, not appropriate, but to avoid the fraction, to avoid longer working, okay, and you want simple expansion, so we will take we will make y the subject from the linear equation. So I will say substitute. Okay, you make y the subject, you bring 2x to the other side. So substitute y equals to 4 minus 2x into equation 2. Okay, so if I do that, what I will get is 2x plus, So I substitute that into equation 2. So my y squared now, if you substitute the y, which is 4 minus 2x, so 4 minus 2x will go in there, and this will be squared. Yeah? So 4 minus 2x was my y, isn't it? I put the y, 4 minus 2x in there. The objective is to get everything in terms of x, only one variable. So if everything in terms of x, then you can solve for x. Okay? So 4 minus 2x squared, that's basically 2 factors of those. So that should be 6. So if we expand it, that should give you 16 minus 8x minus 8x plus 4x squared plus 5. Okay, if I bring the 4x to the left hand side, so minus 4x equals to 0. On the right side will be nothing, so I put 0. So simplify this, I will get 4x squared minus 8x minus 8x, and I have negative 4x here. So minus 8x minus 8x minus 16x minus 4x, that will be minus 20x. 16 plus 4, So take all your constants. 16 plus 4, 20. 20 plus 5 is positive 25 equals to 0. Alright? Sorry guys, that is, what did I say? 16 plus 5. Okay, sorry. 16 plus 5, that will give me positive 21. Okay, so now this is a quadratic equation and we need to solve for x. So first let's try to factorize. Okay, if we can't factorize it, then you know that you could use the quadratic formula. Okay, so let's try to factorize that. So 2x, and you see a constant of 21. So let's have 7 and 3. Okay, so this will give me minus 14 minus 6x. Yes, that will give me negative 20x. And negative 3 times negative 7, that will be positive 21. So there you go. 2x minus 3 equals to 0. 2x minus 7 equals to 0. Once we've got the factors to solve for x, we just equate these factors equals to 0. So 2x equals to 3, x equals to 3 over 2. And the next bit here, 2x equals to 7, x equals to 7 over 2. So these are my answers for x values, but we're not done yet. Once we have x values, we need to find the y values. I'm going to squeeze in here when x equals to 3 over 2. Okay, your equation here just now, y equals to 4 minus 2x. So if I substitute that in there, what I will get is 2 and 2 cancels out. So 4 minus 3 will be 1. And when x equals to 7 over 2, 4 minus 2 times 7 over 2, that will be same thing. The 2's cancels out. So leaving behind 4 minus 7. And 4 minus 7 will give you negative 3. Okay? So you can write down the answers. So answers, x equals 2, 3 over 2, y equals to 1. And x equals to 7 over 2, y equals to negative 3. Okay? And remember when we did the exploration of simultaneous equation, basically it is the point of intersection. So in this case, okay, instead of getting one solution, what we get is two solutions, two coordinates. And these two coordinates, x and y, these are the point of intersection. Okay, you have a curve and a straight line. So a curve and a straight line, for this specific curve, okay, and this specific straight line, it intersects at 2 points. So these are the answers of the 2 points of intersection, 3 over 2y and 7 over 2 negative 3. All right. So guys, substitution method, okay, you look at whichever that is simpler to make x or y the subject, using either linear or non-linear equation. Okay, you will rearrange and to make x and y the subject, and once you've got that, you substitute. So in this case, we have used our first equation, rearrange to make y the subject, and we substitute the y into our second equation. So this y now became 4 minus 2x. Okay, so by substituting that, what it gives us is an equation all in terms of x, and so we should be able to solve for x. Okay, once you've got your x values, do not stop there, because you know that you need to find for y. In our variable, we have x and y, so we also need to find for y. So substitute your x values into your y equation here, and that should give you your y values. Okay, guys? So, you will have an exercise for this, but just one more, okay? Word problem points of intersection. So, like I said before, we have seen that simultaneous equation can be used as a method to find points of intersection. Okay, basically where a curve and a line meet at one point or 2 points. Okay, or a line meets another line. Okay, so here let's have a look at the first example. The line y equals to 5x plus 6 meets the curve xy equals to 8 at the points A and B. Find the coordinates of A and B. Okay, they did not say that they are the points of intersection, but when the question say that the curve or the line meets the curve, okay, when the line meets the curve, basically there is a point of intersection, and in this case there are 2 points, point A and B. So there are 2 points of intersection. So the method here is to solve it simultaneously. Okay, so first things first, what we always do is to label the equation. So that's equation 1 and that's equation 2. Okay, so the next step is to find an equation, all right, and make x or y the subject. So notice that in equation 1, it was already nicely arranged as y equals to 5x plus 6. Okay, and you can tell that that's a linear equation. So I'm going to state here equation 1, substitute equation 1 into equation 2. So what I'm going to substitute is y equals to 5x plus 6, okay, into equation 2. So what that means is that my y in equation 2 will become 5x plus 6. So that will give me x. So now we substitute this in there. So my y now becomes 5x plus 6. Okay, equals to 8. Now, next is to expand it. So that will give me 5x squared plus 6x minus 8 equals to 0. You can try to factorize it first. So that will give me 5x and x. I have a constant 8 here. So let's try with factors 2 and 4. Yep, and then that will give me plus 10 minus 4x. That will give me positive 6x here. So what that gives me, 5x minus 4 equals to 0. 5x equals to 4. X equals to 4 over 5. That is one of my x values. And then x plus 2 equals to 0. X equals to minus 2. Okay, don't stop there. You see that you have variables x and y. You know that coordinates are basically x and y coordinate. So you need to continue to find your y coordinate. When x equals to 4 over 5, okay, you substitute in here. So y equals to 5x plus 6. Substitute the x value. your 5 cancels out. Yep, leaving behind 4 plus 6. So 4 plus 6, that will give me 10. Same thing, when when x equals 2, when x equals 2 minus 2, so y equals to 5 negative 2 plus 6. Basically, you're substituting it in here. Now your x, you substitute negative 2 in there. So that will give me negative 10 plus 6. So that's negative 4. Okay, so you can write your answer. You say I'm running out of space. So the coordinates of A and B are, okay, you have 4 over 5, 10, and negative 2, negative 4. So that is your answer for the first question. Okay, so same thing. Okay, we use substitution method. What we did was we rearrange, in this case, our linear equation. Okay, we did not need to rearrange, but it was already nicely written. Why the subject? So we straight away substitute that into equation 2. But if, let's say, the equation has a different form, what you need to do is to rearrange. You either make x or y the subject, depending on which one is simpler. Okay, you substitute that into the other equation. And when I say substitute into the other equation, it means that now, because I say substitute 5x plus 6, you're going to substitute that into there. Okay, so my y here now becomes 5x plus 6. So I substitute 5x plus 6 in here. That will give me an expression that says x in bracket 5x plus 6. Okay? Alright, so then the equation now becomes x multiplied by 5x plus 6 equals to 8. You know that you need to expand it. What you get is a quadratic equation. Bring 8 to the left hand side. So right hand side, there's nothing on the right hand side. So you put it equals to 0. You get a quadratic equation. First try to factorize it. And if you can't factorize it, you can use your quadratic formula. Okay, find your x values. Once you get your x values, find your y values. Alright guys, so here, the question here already state find the coordinates of A and B. So it means that you need 2 coordinates, 2 x values, 2 y values. So these are the coordinates for x and y that we obtain for A and B. Okay, I will leave the exercise on page 2 for you, and one point of intersection, okay, word problem for simultaneous equation for you to do. So again, practice on your simultaneous equation for nonlinear and linear equations. Okay, you'll get better at it. Okay guys, thank you very much.